Namaste children, welcome to today's maths class. So in the last class we started a new chapter named as algebraic expressions. So in the last class we discussed about the introduction, that is what are algebraic expressions, what are variables, what are constants, what are terms, what are factors and what are coefficients. Now today we are going to discuss about the classification of algebraic expressions, the grouping of algebraic expressions, the types of algebraic expressions based on the number of terms. So here, based on the number of terms, they are classified as monomial, binomial, trinomial, quadrinomial, etc. So now what is monomial? Monomial, the word mono means it is one. We will come across even in the chemistry the word monomers, polymers. So mono means it is one. So an algebraic expression with only one term is called a monomial. An algebraic expression with only one term is called a monomial, having only one term. Example: 7x, 4xy, minus 7ab, pq, 7p square q square, etc. All these are monomials. Monomial means having only one term. Next, the second category is binomial. Bi means it is two. We have come across in maths bisector means dividing into two equal parts. Binomial number system is having only two digits, 0 and 1. So binomial means two. Bi means two. An algebraic expression with two terms. Is called a binomial. It is called a binomial. Example: x plus 2. X is one term, 2 is another term. So two terms are there. X square plus y, 7xy minus 3x. 7p square q plus 6qr, etc. All these are what? The examples of binomials. Binomial means having only two terms. An algebraic expression with two terms is called a binomial. Similarly, the third classification is the trinomial. Tri means three. Triangle means having three sides. You studied. Tri means it is three. So an algebraic expression with three terms is called a trinomial. An algebraic expression with three terms is called a trinomial. Examples: x plus y plus 2z. X is one term, y is second term, 2z is the third term. Similarly, 7a plus 3b minus 4ac. X square plus x plus 2y are some of the examples of trinomials. So even if it is there four terms, we will call it as what? A quadrinomial. That we will discuss in the higher class. So this is the classification of algebraic expressions: monomial, binomial and trinomial. The other one, it is the polynomial. Poly means many, one or more than one term. An algebraic expression having one or more than one term is known as a polynomial. It means that all monomials are polynomials, all binomials are polynomials, and all trinomials are polynomials. Is it clear, children? Yes. Now polynomial. Poly means many, that is one or more than one. Polynomial means an algebraic expression with one or more terms. Means it may contain one term or it may contain more than one, means two terms or three terms or even more. Such expressions, algebraic expressions, are known as polynomials. It means that all monomials are polynomials, all binomials are polynomials, and all trinomials are also polynomials. Examples: 7x is a monomial, it is a polynomial. X plus 2 is a binomial, and it is a monomial. Sorry, it is a polynomial. X square plus 3xy plus y square. Sorry, 4x minus 7z plus 3y are some of the examples of polynomials. You will study in class 9 about the second chapter is the 9 and 10 polynomials chapter is there. We will discuss more in detail about the polynomials in the class 9th and 10th. Now what we studied, with this knowledge we will solve the questions from exercise number 12.1, the first exercise. Yes. Now, exercise number 12.1, the first bit. Get the algebraic expressions. Get the algebraic expressions in the following cases using variables, constants, and arithmetic operations. What are arithmetic operations? Addition, subtraction, multiplication, and division. So, using variables and constants and the four arithmetic operations, we have to write the algebraic expressions. The first question. Subtraction of z from y. Z is subtracted from y. So what will be the expression? Z is subtracted from y. So first y will be there. Y minus z. Y minus z. The third question here we have here it is the number z is multiplied by itself. Z is multiplied by itself. That is z into z. So what we get? Z square. Z square. Z into z it is z square. Next, the fifth bit here we have the numbers x and y both squared. Two numbers are there, x and y, and they are squared and then added. So when x is squared, what we get? X square. When y is squared, what we get? Y square, and both are added. Therefore, what we get? X square plus y square. X square plus y square. Then we have this seventh question here. We have the seventh question. Product of numbers y and z. Two numbers y and z, they are multiplied. So after multiplication, the result which we get, we call it as product. So the product of y and z and is subtracted from 10. It is subtracted from 10. So first 10 will be there. From this, the product of y and z, that is yz, is subtracted. Therefore, it is 10 minus yz. Like this, we will write the algebraic expressions. So, read these statements correctly, understand them, and we can write them in the proper way. So, this we have studied even in class 6th. In class 6th algebra chapter. Clear, children? Yes. Question number 3 from 12.1 exercise. Identify the numerical coefficients of terms. What are numerical coefficients? Numerical coefficients are nothing but numerical factors. Numerical factor of a term. Other than the constants, exclude the constants and identify the terms. Write their coefficients for the following expressions. Here we have some of the expressions. The first one, expression, it is, what is the expression here we have? The first expression is 5 minus 3t square. Exclude the constant here, 5 is a constant. Then what is the term other than constant? It is minus 3t square. Now what is the coefficient of minus 3t square? It is nothing but the numerical value which is minus 3. That is minus 3. Next, the third question here we have the expression, it is x plus 2xy plus 3y. Here we have three terms are there which do not have any constants. There is no other constant term. All are algebraic terms are there. So what are the terms? X is one term, 2xy is one term, and 3y is the other term. For x, what is the coefficient? There is no number which is always 1. That is plus 1. And 2xy, 2 is the coefficient. 3y, 3 is the coefficient. Next we have the fifth bit is there here. It is minus p square q square plus 7pq plus 7pq. So what are the terms which we are having here? The two terms, that is minus p square q square. The other term, it is what? You can write 7pq is the other term. Here I am writing minus p square q square. What is the number here? There is no number, means it is always 1, and we have minus sign is there. Therefore, it is minus 1 comma 7pq. This numerical coefficient is 7. Numerical coefficient is 7. Next, we have the seventh question. It is 3.14 r square. Only one term is there. That is 3.14 r square. Therefore, what is the numerical coefficient? It is 3.14. 3.14. Next, the ninth question here we have the ninth question. 0.1y plus 0.01 y square. So what are the terms? 0.1 y, the other term it is 0.01 y square. So 0.1 y, what is the coefficient it is? Yes, it is 0.1, and the 0.01 y square coefficient will be 0.01. Like this, the here numerical coefficients are nothing but the numerical factor of a term. Is it clear, children, how to write the numerical coefficients of the terms of the given following expressions? Yes. Now exercise number 12.1, the question number 4, that the A bit. Identify the terms which contain x. Identify the terms which contain x and give the coefficient of x. Here we will find the n number of terms, but for few terms it may contain x as the one of the variable, or all the terms also may contain one of the variable also here. So now here some expressions are given. We will write this in the form of a table. Expression and term with which contain x, term with x, and coefficient of x, like this you make a table and it will be easy for us to write. The first question here, the expression is y square x plus y. Here two terms are there. Y square x is one term and y is the second term, but second term y did not have the x as the variable. So only one term is there which is having x, that is y square x. Now what is the coefficient of x? Other than x, the remaining all will be the coefficient of x. Other than x, what we have here, it is y square. Therefore y square is the coefficient of x. Next, the second question here we have 13y square minus 8yx. So here two terms are there. 13y square, there is no x. Second term minus 8yx, we have x is there. So which term it is? Minus 8yx. Now what is the coefficient of x? Other than x, what we have? Minus 8y. Now the third question here we have. The third question, x plus y plus 2. x plus y plus 2. Here x is there only for one term, that is x. X in the sense 1x. Therefore its coefficient will be 1. Then again the fifth question here we have 1 plus x xy. 1 plus x xy. Here two terms are there with x, that is x is one term, the other term it is xy. So now what is the coefficient of x here? It is, yes, it is 1. And the xy, what is the coefficient of x? Other than x, what we have here, it is y. So it will be y. Then the seventh question here we have. The seventh question, 7x plus xy square. 7x plus xy square. Here two terms they contain x, that is 7x is one term, the other term it is xy square. Therefore what are the coefficient for 7x? It is 7, comma, for xy square the coefficient is other than x, what we have? Y square, that is y square. Two terms, space is not there, I wrote adjacent to each other. Like this we will identify the terms which contain x and their coefficients. Sometimes we may get the question, identify the term which contain x square or y square or z or y. Like this n number of questions can be asked. In this way we can solve those questions also. Is it clear, children, how to identify the terms which contain x? Yes. Now the fifth question from exercise number 12.1. Classify into monomials, binomials and trinomials. We should categorize the given expressions as monomials, binomials and trinomials. What are monomials? Monomials are the algebraic expressions which contain only one term. Binomials means algebraic expressions which contains two terms. An algebraic expression which contains two terms is known as a binomial. Similarly, trinomial means an algebraic expression which contain 3 terms is known as a trinomial. So express this in the form of a table. So it will be easier and we can save the time. So monomials, then binomials, and then trinomials. So you write them separately, binomials, trinomials and monomials in the table. First one, 4y minus 7z. How many terms are there? 2 terms. Therefore it is a binomial. 4y minus 7z. Second question, y square. Only one term is there. Therefore it is a monomial. Then third one, x plus y minus xy. X plus y minus xy. 3 terms are there. Therefore it is a trinomial. X plus y minus xy is a trinomial. Then the fourth question we have here, 100. Only one term is there. Therefore it is a monomial. Then fifth question, ab minus a minus b. 3 terms are there. ab minus a and minus b. Minus a and minus b. Then sixth question, 5 minus 3t. 5 minus 3t. 5 is one term. Minus 3t is the second term. 2 terms are there. Therefore it is a binomial. 5 minus 3t. Seventh question, 4p square q minus 4pq square. 2 terms are there. It is a binomial. 4p square q minus 4pq square. The eighth question, 7 into m into n. 7mn. A single term. It is a monomial. 7mn. Then the 10th question, a square plus b square. 2 terms are there. Therefore it is a binomial, a square plus b square. Next we have the 12th question, 1 plus x square. 3 terms are there. Therefore it is a trinomial. 1 plus x square. It is a trinomial. Like this we can classify by looking into the expressions. If they contain only one term, it is a monomial. If they contain 2 terms, it is a binomial. If they contain 3 terms, it is a trinomial. Yes, now we will discuss the second concept of this chapter, that is addition and subtraction of algebraic expressions. Like fractions and unlike fractions. Like fractions can be added and unlike fractions also can be added. But here, like terms and unlike terms. Like terms can be added and subtracted. They can be added and they can be subtracted. How they can be added and how they can be subtracted, it is quite similar for both addition and subtraction. It is similar for both addition and subtraction. How we will add? The sum of 2 or more like terms. The sum of 2 or more like terms. We are discussing here. It is like terms. Is a like term. It is also a like term with numerical coefficient equal to the sum of the numerical coefficients of all the like terms. So how we will add the 2 like terms? We will add just numerical coefficients of the given like terms. We will add numerical coefficients. Numerical coefficients means numerical factors. We will add them and we will write it as also a like term. We will write this as also a like term. So when we add 2 or more like terms, we will get a like term. We will get a like term means what? The variable, that is algebraic factor, is same. Algebraic factor will be same. Just we will add the numerical coefficients. For example, 7x plus 3x plus 2x. These 3 terms are like terms as they have the x is the variable, x is the algebraic factor. Then what we will do? You just add the numerical coefficients of all the 3 like factors, that is 7, 3 and 2. Add 7 plus 3, 10, 10 plus 2, it is 12, 12x. Similarly, 4xy plus 3xy is equals to 7xy. Add the numerical coefficients 4 and 3. 4 plus 3 it is 7, 7xy. Here the algebraic factor is xy, the like terms. So again the sum also we are getting a like term with the algebraic factor xy, which is same for the first 2 given like terms. So how do we add like terms? we will add just the numerical coefficients of the given like terms. Similarly, how do we subtract? Yes, the difference between two like terms, the difference is nothing but the result which we get by subtracting. The result which we get on subtraction is known as difference. The difference between two like terms is a like term. This is also a like term, means they have the same algebraic factor with a numerical coefficient. They will also, the difference also will get a numerical coefficient that is equal to the difference between the numerical coefficients of two like terms. So similarly here also we will subtract the numerical coefficients. We will subtract the numbers, that is arithmetic numbers, and we will take the common algebraic factor as all are like terms. Example, 7x minus 3x. 7x and 3x both are like terms. Just subtract the numerical coefficients. What is the numerical coefficient in the first term? It is 7. Second term it is 3. Subtract both the numbers. 7 minus 3 will get 4. 4x is the difference. Similarly, 10 pq minus 4 pq. So 10 minus 4 is equal to 6. 6 pq will get the what? The difference of the two like algebraic expressions. So like this we will add the like terms and we can subtract the like terms. Two or more we can add, but two like terms we can subtract. What about unlike terms? Unlike terms cannot be added or subtracted and are retained. We will leave them as it is. We will leave them as it is. We cannot add them and we cannot subtract. For example, you see here 7x plus 7y. 7x plus 7y. When we add these two, 7x plus 7y, as they are unlike terms, we cannot add them. So we'll get the same, that is 7x plus 7y itself. Unlike terms cannot be added or unlike terms cannot be subtracted. You take here it is 7x minus 7y. Again we cannot subtract. That is we get the same 7x minus 7y itself. Is it clear, children? How the like terms are added or how the like terms are subtracted. What about the unlike terms? Clear? Yes, I hope you understood today's concept, that is the classification of algebraic expressions as monomials, binomials, trinomials based on the number of terms. Polynomials are the algebraic expressions which contains one or more than one term, and the classification we studied, and the addition and subtraction of algebraic expressions, that is the like terms and unlike terms we have studied. With this knowledge, your homework is exercise number 12.1, question number 1, question number 3, question number 4 B bit, and question number 5. The leftover sums you can do as your homework. Thank you very much.